generation of a token commitment. So essentially a hash of all the different data elements. We sign those elements, and when we sign those elements, we sign them under zero knowledge, and we send those signed document. Now, for example, in the case of baseline, one of the most prominent ways after Whisper in Radish that we have used in baseline, or we have come across in baseline, is using NATs. So NATs could be used as a as a microservice, or as a scale set of a microservice, which could be used for essentially managing the secure message communication. So we send a signed commitment, the party B receives a signed commitment, essentially a repeat of this process or an inverse of this process. And then by this point, we could say that both parties have mutually agreed upon the terms of the token, and the different terms by which, say, factoring could be done, or say even simplistically, some condition could be like, if the current date of paying this invoice or tokenizing this invoice, or essentially minting this invoice token, is timestamp to be now, if that is, say, greater than some end of the year or end of the month, then reject this or value it in a different manner or something to that extent. So essentially, any of those business constraints, along with the token values itself, the hashes of the token values itself, are something that could be composed in one proof. There are technical considerations around how we would go about composing proofs, and and the underlying infrastructure and technical considerations around it. But from a flow perspective, the idea is that once the co-signed document has been received, and it's at this point of time, the proof generation now implies the consistency of the token in both systems, i.e. party A and party B, secured under zero knowledge. And also, from a consistency perspective, both have the same view of the data as before generation of the proof. Then a proof is generated under zero knowledge, and the proof is verified on the mainnet. The important aspect, again, as at least from this breakout session, at least we can assume that it's commonly held for the purpose of this audience in this breakout session. I mean, we can assume that it's commonly held that when we are verifying the proof, it essentially means that we are not committing any data to the chain and anything about the token, the value, the parties involved, or anything, or their signatures even, or anything to that extent. But we are essentially verifying the fact that all of that information has been proved based on these business constraints under zero knowledge. And in such a manner, we operate on the mainnet to verify the proof using a combination of storing the token hash on the mainnet and then minting a token, which essentially represents the invoice. I haven't covered the aspect of transfer because there may be other aspects of what could trigger transfer of the token, and that could mean a similar sort of a process where it is an update of a token commitment instead of a generate of a token commitment when there are transfers involved, and so on and so forth. But essentially, the idea is that by this point, a proof is generated, which essentially represents the fact that token has been minted under zero knowledge, ensures consistency of the data that it represents on the mainnet. And the final point is just a proof verification step, or proof the proof validation of the proof verification step. So essentially checking the proof, and that check of the proof can be done against the shielded contract, where all these transactions for these tokens or for baselining of that particular token itself at large has been committed to a shield contract, and in that sense, it's a shielded transaction. So that's the overall flow of what, from a business process perspective, what we are at least trying to envision it as, or at least in terms of discussion so far, what has been coming out. And in terms of this discussion, I would like to now open the floor up to just generally see if there is any dialogue we can have or any way we can ideate around whether this idea of tokenizing and or tokenizing as it fits to baseline makes sense. What are the other patterns that you are noticing around around where it makes more sense to focus on other aspects of the token factoring as opposed to just baselining it.
Hey Thomas, thanks for joining us. Sorry, Kartheek. Yes, that makes sense.
Had some trouble to join.
Yeah, that was my fault. Zoom experiment. But yeah, we made it. And so, Martin, what do you think?
I'm not sure. Coming back to the flow, I'm not really sure. What is on-chain, off-chain, where you do a zero knowledge proof, and what you do with that. I think I grasped a few of the things, but most likely not the complete process. So I'm not sure what makes sense, not what you really understand with a token commitment. I haven't seen, when do you create the token though? The 1155, is that created when you actually mint the token at the very end?
Yep, that's right.
Mm-hmm. Yeah.
What of those boxes is on-chain?
Anything related, everything that is in between party A and party B is essentially representing the chain. Mm-hmm. And just so that it clarifies, when you say commitment, it's just a hash. Just assume that it's a generate token hash.
But this hash is not stored on chain. That is directly exchanged with the other party, I guess, or not. But Alice and Bob just communicate on a secure channel off chain, I guess,
and the hash is stored. I mean, in this representation, the hash is stored in the shield contract. So when the verification
at the very end, if the handshake has happened and they have proven it, if I get the picture right, how do you handle actually the data which is behind that token commitment? So we know, hey, the invoice data itself, is it shared with party B or is it not?
So your question is if the data that party A uses in the, say, generation of the token hash and so on, is it visible?
Yeah, I guess party A is most likely the owner of the document, or not?
Yeah, you could say that they are issuing the invoice. Yeah, in
the
perspective.
The originating party.
They use some hash function, I guess, to create that token commitment, whatever, merkling the document fields, or I have no idea. And then this hash is actually what's traveling through the process. Does party B know about the invoice and the invoice details, or they only have a proof that the data was correct under some certain assumptions, rules?
What would be cool?
Yeah, sorry, go ahead, Kyle. I think you're on.
So yeah, well, I was just going to say what would be cool. It would be to to be able to verify that the invoice reached. I don't want to use the word finality because it sounds like the blockchain, but like it reached finality in a business process to the point where it can be at that point converted into a financial instrument, meaning it as like a way of reducing fraud in the process. And so essentially,
my question is much more basic. I just would want to know what party B represents. Is it also a recipient of the invoice? So it's okay that you share the data, the invoice data with party B, or is it another party? So let's say, in the invoice factoring process, maybe someone who is has a different function in the process, and did not get the data, or not at least entirely.
So initially, I think party B is the organization that received the invoice. But I think, to your point, there could be a party C that does some other sort of attestation or other sort of service, and they may have different visibility into the process. But I think that's sort of a follow-on step to this first sort of pass. Does that sound right, Kartheek, to you?
Yeah. I think that's a very good question, actually. I mean, what is party B and what's the role of party B? Here, in this case, as you said, Kyle, it may just be the receiving end of that particular invoice, because ultimately the invoice is to be sent to to say the receiving entity to be able to settle it or to be able to convert that invoice into payment at some point in time.
Yeah, and that's one thing I've been looking into in the protocol side for the baseline protocols, being able to have a flag where not just the proof or the commitments can be sent over the wire over the point to point via NATS, for example, but like you can have a flag that enables the full payload to actually go as well.
Yep. And also the other point is around the attestation piece. So I think that actually brings in a whole new aspect of what are the other areas and who should actually be generating the proof. Would actually party B, would there be a case where party B also would have to generate a new proof before party A gets to generate the proof? Like for example, in the case of attestation, if party B is playing the role of say some mediator or arbiter of transactions or of these token representations and custodies and so on, like for example, if party B is a custodian, for example, and if and party B is say just attesting, essentially giving a verifiable claim that this particular invoice has such denominational value and it belongs to certain party and it has certain terms. So essentially, it's just not just signing the document in that sense, but it also has to generate a claim and it has to prove that that claim is right. So it may have its own sub-process to generate a different proof. And at that point of time, we're talking about a flip scenario of what's happening between party B and party A before this generate proof itself. Like I'm not trying to complicate it, but I think it brings in a whole aspect of other use cases as well, which is quite interesting.
And the highlighted parts is that zero knowledge proofs already, or I mean the generate token commitment and the generate proof, or how do I read that?
Yeah, it's a very good question. So in this, like, try to represent how different services are involved in a baseline specification. So where it represents the yellows, it's supposed to mean it's a privacy-oriented process, or there is an involvement of creation of either a token hash or using under a certain hashing scheme. And certain signatures and also generating some signatures so that when you're generating the token commitment itself it's a hash of the token hash as well as the signatures. So essentially the generation over here represents a creation of a zero knowledge proof. The proof is not yet verified or it's not yet submitted to the blockchain. It's because that proof needs to be embedded with certainty of this signed commitments being sent. So its proof is first created or prepared or bootstrapped in a very loose sense in this step. Then an API process or your internal process that can actually handle signatures. The idea is that this could be a plug for other sorts of signature mechanisms that could come in, but the idea is that this is a signature outlet. And then this darker one represents P2P communication, like either using Whisper, or it could be using Layer 2, or it could be using NATS or any other sort of technology. And following the same legend, the main things that are associated with interacting with the blockchain are all these light gray boxes where you're verifying the proof and so on. So to your question, the zero knowledge based processes are the yellow here and the yellow here.
Get you. The link to the underlying document is how do you make sure, you know, if party A has an invoice, had already guess on one of those P2P channels you have managed, sent that to party B, how do you reference to that invoice if you later on start a tokenization process like this? Making sure, you know, that party B knows what document to talk about and what to verify.
Yeah, that's a great question. we'll so the way we are handling it, or representationally at least the way we handled it in Radish, and we're trying to follow somewhat similar process but more optimized in terms of saying that any proof needs to essentially satisfy a few standard, not standard, but at least say quote unquote templated statements that need to be proven. One is about its own consistency, which is the fact that its hash, the hash of that particular document is essentially correctly formed, or the hash is correct. Then the second statement that we want to prove is that it has been signed by the intended parties. In this case, party A and party B, both their signatures, and both their signatures and the signed document. So essentially, you have proof one, which is measuring for consistency. Proof two, which is measuring for signature verification.
What is the consistency measured against? Is the document coming with the P2P message itself? Or yeah, okay. Then again, my question actually is, if they have exchanged an invoice already, and then I, as party A, the issuer of the invoice, would actually generate a token. How do I tell party B that the invoice I'm sending here should be already in their system under whatever, what party B actually needs to do, I think, if it comes to business process itself, they actually need to verify it, not just, they do not just need to make sure that the message itself is consistent, so that the hash meets the document data, but so just reverting the hash function. Also party B actually has to find its own system, the original invoice as it was received, as it was validated, and whatever, went through the internal incoming invoice approval, whatever process in SAP, Microsoft Dynamics, I don't know, and actually check that the data is actually still the same and valid and hasn't altered, how do you do that?
That's a good question. So I think right now, from a party B's perspective, the scale set is that there is underlying API or underlying functionality is there for party B to independently take the information that has been sent by party A to hash that particular information and verify again that the hash or the document's hash that has been sent is indeed the correct hash of that particular document itself. So there is an independent necessity for party B to have their own hashing mechanism if they need to, or not hashing mechanism, but hashing function or the same hashing library for them to be able to use to generate the same data. But in terms of the actual document being sent, the idea is that this sort of process of creating this hash, signing the hash, and then having this secure messaging layer where it could be even by a queuing system where any form of current P2P or any form of P2P technologies, or even if for that matter, if the choice is to send using legacy APIs or using legacy SAP or ERP systems APIs to trigger a message from party A to send it to party B. And then once party B receives it, they can update their local systems as a synchronization process. So the idea is that, yeah.
Then let me change the I think I'm still not at the point I would like to address, So what would happen if, I'm party B, you party A, you have sent me an invoice, if you have received the invoice, all that went well, exactly as you have described, and I actually then return the invoice back to you. And that also went well, just the other way around. But then for the tokenization, you sent me an older version, not the version I have returned to you, but the version you initially sent. And then, of course, the validation process internally in my system is failing because it's not the latest and current version of the document. It's a former version. Is this missing consistency? Is this considered? And how actually I'm, as party B, can be able to reject the invoice? The message itself is consistent, the hash function works, but I actually not, but the consensus actually the consensus between party A and party B is broken.
Yeah. Sorry.
No, I was just, I mean, it's, go ahead. I can chime in.
Yeah, go for it.
I mean, I think it works a lot like GitHub, you know, in the sense that the commitment that you create is based on previous known commitment. If someone beats you to the punch, like the invoice has changed, that like a new commitment would have been generated on what would have been likely the same base or the same route that you generated. You know, you have a race condition, and so I think to Kartheek's point, some existing technologies that you know in the messaging space, the peer-to-peer, point-to-point, peer-to-peer and point-to-point messaging space, combined with locking, can solve a significant number of issues there, as well as like being able to automatically rebase, essentially, like in a similar fashion to GitHub, how Git works. If a commit is found to be inconsistent at the time of application, you can basically run a diff and see if the changes conflict, and if they don't, you could automatically attempt to merge that in on top of the latest route, essentially.
Mm.
Stefan had a point.
Okay.
Stefan?
Oh.
Hello.
Hi.
You cannot hear me, I guess?
Yes, we can.
Ah, okay.
You're a little bit the volume's lower than usual, but yeah, I can hear you.
Okay, yeah, sorry, dialing in from the mobile phone. And by the way, Martin, nice to meet you again. It's been a while, but great. I think the question that Martin is bringing up is actually the same that we tackled during the SAP Dynamics integration. And it has mainly to do without linking the actual documents that are exchanged and verified. And I mean, the basic solution that how we did it in the demo was that each of the documents that follow up on each other and are exchanged between party A and B link to the former document just by one part of the agreement. So, for example, if you have in this case the token commitment, which is signed by both parties, and then you have a token generation event, I would understand it in a way that this token generation event somehow links to the underlying document that was there in the first place. So in our case, it were a request for proposal, and then the proposal that was answering this request linked to the say ID of the request for proposal, including the hash of that very first document to be part of the hashed attributes of the second document. So by this technique, you know that each time, if you see the tokenized invoice and one of the attributes is the ID or the hash or even the content of the first document, then they are linked in terms of when they're proved and verified. So I don't know if this was the question, but at least
I guess it was a question. So if I understood you right, the process for just transferring a document like the RFP or whatever, between party A and B is exactly following the same process, I guess. And then at the very end, if party A is sending an RFP to party B and party B is confirming that they have received the RFP, this is then also, I guess, creating a proof again, and that is stored on chain in the Shield contract, I guess. And then the next cycle is referring to that one.
Exactly. It should be at least for those parties who are actually exchanging the document. So if there are third parties involved that somehow have to verify the proof without actually knowing the, let's call it, payload of the message itself, then it's a different thing. But between party and A actually doing business together, this is what Kai was talking about earlier. Just to introduce this flag where you use the end-to-end communication to also include the actual payload of the object itself, of the business object, to replace an additional messaging layer or an additional integration layer that you would have to build, but just have it implicitly as an option within the baseline pattern.
Yep. and to use, and when you have like the shared, a Diffie-Hellman shared secret, for example, between the parties, you know, it's implicitly encrypted on the wire, regardless of what the, you know, what messaging protocol you're actually using.
Yeah, which is actually not important. You know, I think any kind of peer-to-peer protocol which is somehow, you know, public-private key encrypted should work more or less, I guess. Yeah, just depends on, you mentioned if you like Whisper or whatever.
Yeah, it's more of an implementation detail for sure.
Mm.
Yeah, I think that's one of the things that when we talk about linkage as well, when what we do is when we're creating the proof of a particular document, even now, as Stefan was alluding to, and right now it's currently being handled in one of the branches in our line of in the baseline code packaging part of work, is a most general circuit or a most general proof would essentially entail also the linkage concept, which is where the third statement comes into picture, which is the aspect of how you're storing or an object linkage in the Merkle tree, how it Merkleizing the linkage process itself. So what we're essentially trying to do is that there is going to be an off-chain Merkle tree. Instead of trying to verify the creation or storage of the because essentially when you're Merkleizing, what we're trying to do is we're pushing a hash into a Merkle tree on the chain. And when we want to update that particular hash, we will need to have a process to update that particular hash, whether because that document state has changed or say some action has to be taken on that, for example, creation of a token, and therefore it needs to be updated, the state of that needs to be updated, or a certain flag needs to be updated, or more generally speaking, when we need to link a particular hash to a different hash. So what I mean by that is, say for example, invoice is linked to a previous delivery notice. Delivery notice will essentially say that once both parties have agreed that the delivery notice has occurred, and both of them are consistent in terms of saying that yes, both of them have the same, both of them are talking about the same product or same invoice or same whatever the reference is. Essentially, the idea is that invoice is referring to the delivery notice. So embedding the delivery notice as a part of the hash of the invoice as a first step, then verifying the signatures as part of that particular check, and then thirdly, making sure that when you insert this hash into a Merkle tree, what the root that you calculate or whatever the Merkle tree representation should be on the chain, you're already computing that step off chain first. So when you're submitting the proof, you're not causing the chain to create or update the state, in the sense that we are not causing it to run an extra computation or an extra evaluation to check whether or not the association is right, but rather we are whatever we do with single document, we are doing the same thing with the relationship aspect of it. So essentially, baselining of a document means that you're not just making it consistent to have the same representation of the document at two endpoints, but you're also Merkleizing the relationship, which means that anytime a future process needs to be created, let's say, for example, now payment needs to be created. When a payment is created, what it could do is that it could use the same Merkleization of relationship concept to first recalculate what the Merkle tree should look like when this particular payment needs to be issued, and then using that as a basis of the proof before issuing the payment. So in that sense, having a proof that is composed of consistency check, not just for data, but also for the trace. It doesn't even need to do the trace of the entire like chain all the way up or all the way down. All it needs to do is just trace out the immediate next step, like a linked list. So that way you can traverse back and forth depending on how the verifications happen on the chain. And also because you have your own P2P system and your own invoices and so on, you can also check proofs as in the final step. So that's sort of the, like, at least the direction we've been going technically, like under the hood, as to what it means to represent that the relationship is intact between parties. To assume that there is a starting point before we start a Merkleization, so that we assume that a new event is essentially a delta from an origin, and we assume there is an origin. By default, there needs to be an origin.
Okay, understood.
So one of the things I wanted to touch upon, or at least bring about, and as we were preparing for this session, was that it would be great to see, like, or at least this is again what we discussed so far is a very maybe quote unquote technical, or going under the hood as to how certain principles are managed. But apart from this one concern around how consistency is managed before creation of an invoice, in terms of its actual representation of where it could be handled as a DeFi sort of marketplace, I think in one of our previous sessions, we were on baseline, we were discussing around how, for example, centrifuges ecosystem could be a place for having invoices to be able to split them or tranche them and sell them in different marketplaces, or even deal with exchanges directly. I just wanted to touch upon that and get your insights, or get insights from everyone on this group.
I'm not sure what you're targeting and what to aim for. So just remembering the conversation we had in the steering committee meeting, the last one, where I actually, was lost a little bit, is if baselining a document actually creates a consensus between the involved business partners who also share the payload of a message in private peer-to-peer channels. And on-chain, there is actually only a hash without any relationship, just enabling a proof of the data, where you, I guess, with any third party can prove that some specific questions can be answered with yes or no, I guess, but nothing else, most likely. For any other scenario, you need to share the data again with the other third party, and then they can use the on-chain hash to do an off-chain verification, I think. That's the Merkle process you had described, I guess. And how that works is any DeFi protocol, where a DeFi protocol, per definition, has to be decentralized and has to be on-chain and has actually to have access to the values, where the smart contracts itself actually have to have access to certain values to do a value of exchange, to do calculations, to do proofs, and I'm not sure how that can actually be done in a decentralized manner. Where I think, I'm not sure, how if there is a concept for that, or how would that work, Is it multi-party computing or whatever,
That makes sense.
Yeah, makes sense. I think one of the things that we were thinking was also around. Sorry, did I cut someone off? Someone was trying to talk.
What's that?
I thought I cut someone off.
Oh, no.
No. Okay. Okay. So I was just talking about how when we're one of the areas that has been sort of under consideration, but we haven't looked too much into it under the hood, also because we have not, or at least in the small set of people that I've been speaking with, the focus has not been so much on the aspect of, say, layer 2 solutions to achieve this sort of multi-party consensus or on the state of a document and so on. There are, at least from what I read, there are good solutions out there using layer 2 networks. For the most part, in the path of where we have reached in terms of baseline, the underlying assumption is that you have the mainnet as a frame of reference, and therefore you don't. We may not necessarily need a secondary network also to achieve consensus. The consensus problem is sort of getting solved by the mainnet. But if you need to have like a secondary form of consensus on your own, then it shouldn't technically stop you from having your own second layer of multi-party or layer 2 network, so to speak.
No, that's not what I'm saying. What I'm saying actually is if the mainnet is just a source of reference, let's say the single source of truth and not more, I basically cannot use it for a decentralized protocol. So I just question if baseline at all works for DeFi.
Well, it's the consensus for, wait, I didn't follow that. Why not? Why would you not be able to use it?
Yeah, it needs a token which has a value, which can be verified, and which can be used in one of those protocols where the logic is on-chain, and the logic just has to be fed with values, and then the values aren't there and cannot be provided. How should it work? You know, I'm not sure. How would you like to lend something on Compound, switch swap tokens on Uniswap or whatever within token, which is completely shielded? You know, it's my question.
Perhaps it's just two parts of a process. So
Exactly.
meaning the negotiation between parties to reach the point where they actually agree on an invoice that was the last step in a complete procurement process, and then afterwards tokenizing it. It doesn't necessarily have to stay within a baseline all the time, at least at my understanding. I mean,
Yeah.
It could be just the initial start point for creating the token, just like you would have done without baseline. I don't see it as a stopping sign. It's rather an integration point from where the business process leaves baseline and decentralized tokenization process starts. So
Yeah,
just as a thinking pattern, perhaps.
Yeah, I see like the document itself having like the first 4-byte like method identifier baked into it, and that would what that would do is it would point at the what mint function to call on the token within the token registry. Essentially, I mean that's just like a rough, not to get too deep into the weeds, but like that's just sort of like an off-the-cuff vision that I had in terms of how it may be standardized into the generic document that we have created in baseline. And so maybe that sort of gives you some perspective on how where the handoff might come from, at least.
To give you an example, you know, let's say, hey, there's a logistic exchange, and logistic exchange, as we know it, is a marketplace, and then actually, hey, I need to get something delivered from A to B. Till then, you know, it has to be cooled with whatever temperature. You have to handle it with care, blah blah blah. All the details actually, and I think if I understand baseline correct, actually travel to this marketplace through a private peer-to-peer channel, and then you use actually the baseline protocol, so the baseline actually hash value to verify that the data is correct, cannot be tampered, and that later on party E sending such an RFP for transportation cannot change the data in the system anymore, because you can prove actually, hey, at the time I've sent that to that exchange, that was the data. And everyone in this exchange can also rely on the data. And publicly on-chain, you do not need to share anything. But if you now actually take this exchange and put it on-chain, think of Uniswap version 2 or whatever, where a smart contract is actually kind of reconciling supply and demand. How should that work? That is deep.
That's the question. That's the question that we need to answer. That's why we're here, for sure. It's a good question. We're going to find out, Martin. That's what I would.
I do not have an answer, so that's why I ask this question.
Yeah. I mean, I brought up the aspect of layer 2 mainly because some of when we talk about representing tokens or transferring them across by using singularly the mainnet, there are cases where asset exchanges can still happen on other networks, like for example, other public ledgers, not just Ethereum. So asset transfers could happen either in, say, Bitcoin or Zcash, or even for that matter in.
Yeah, but that is actually not changing the issue, or not. If you do it on another mainnet which is public as well, even if it's permissioned, you share the data with everyone who is participating in this permission club. So that even isn't changing it, So and Zcash, hey, that is something where the transfer itself is, I think, shielded. But if you would like to use the data itself really to calculate it, not just sending data from A to B and kind of shielding where it's coming from, who is it going to, and things like this, it's where I do not really have a good answer, So how actually to make that in a private way. So I think you can shield few things, like what I've mentioned, like most likely where it's coming from, where it's going to. But what is essential for the logic itself, like what is the value of a specific token, that is most likely really hard to, I think, to abstract away using zero knowledge proofs.
Yeah, I think that's a very good point, because that's where I think I think one of the notions of saying that, let's start with the point that if I am trading an invoice or a letter of an invoice which is of denominational value of 10,000, say 10,000 units, or say, for example, $10,000. And I would like to offset that because I can only fulfill about 50% of it. And this is a common scenario that happens in procurement, but in other, and we can talk about other use cases that it would happen as well, like generally in terms of general like domain of how it could apply or where it could be applied. But the idea is that if you're starting off with the notion that both of them agree to the fact that one, say, denominational invoice token can be exchanged for some XYZ services. Now, it's a good question that you point out that if there are multiple areas where, like, for some may be using permission ledgers, some may be using permissionless ledgers. It's almost like it depends on which area or where you're trying to settle that particular transaction, I think, in which ultimate currency you want to, or ultimate base ledger that you would want to use to settle it down in. Because until that point of time, it's still an abstract notion of a conversion factor. I mean, I don't know, like it almost makes me think that maybe it's a good area for some sort of interledger oracles to be out there who can manage this sort of conversions or the sort of denominations, or at least hold these contracts for managing these. I don't know.
I'm not sure if it helps, just it's a bridging blockchains, IBC, proxy, smart contracts, etc. and so on. I'm not sure that really helps here, because you still have the issue that there is public logic which has to be actually be on the blockchain, and has to be public actually to make sure that's following the rules, that's not tampered, and that you do not need an intermediary anymore. And how actually to abstract away completely, I am not sure how to do that. I think Enigma is going in that direction and trying to achieve those things. But I'm not sure if you're looking at those things.
Yeah, I mean the aspect of yeah, we can definitely when it comes to like multi-party computation or multi-party key distribution to exchange to ensure that states are always in sync and managed, and you're ensuring consistency of data. And more or less, many of them use some sort of variations of different formats of secret sharing. It could be splitting it into multiple shards of a particular key based on different addresses, and then managing the state change everywhere. I know
how it basically works. You know, no, my question is for actually, if you consider those things to being part of baseline and exchanging documents through baseline as a standard, or not, or you just actually say, hey, baseline is really this pure document exchange, like, you know, acting as a, let's say, decentralized middleware, where actually, you know, you do not need to rely on someone kind of, you know, taking care of the data and making sure it's not changed on the way, and also, you know, to have a consensus between the parties. That is great, but I think then I'm most likely do not know how to really integrate that into those decentralized protocols, like whatever is DeFi, you know.
Yeah, so I think in that sense. Sorry, please finish what you're saying.
Because the power of those protocols actually is exactly that you actually destroy a middleman and put the logic on chain. You know?
Right. Yeah. I mean, agreed. I mean, to your point on Enigma, I've seen, and your question around baseline. I for one, I'm not definitely advocating that baseline is hardlined to only consider layer 1 solutions or ETH 1.0 solutions and only use the mainnet hard and fast. But the idea is to see what there could be other areas of exploration as well that could actually solve some of these issues where you might not need the mainnet to actually achieve this sort of consistency. And to your point, it could be something to the extent of using something like Enigma's protocol. And I think, if I'm not wrong, this came up in like one or two of these discussions on Slack and some of these committees, steering committees around, even when you talk about an RFP process, and now when you talk about multiple parties signing it and not just two parties signing it, to achieve this a consistent state of an RFP, for example, what would be some directions to go forward? I mean, again, if you talk about it from a zero knowledge point of view, then there is no signature scheme as such which could uniformly verify everything else, and at least it's in the making, but it's going to take some time. Or at least from what we can say, technologically speaking, it's going to be available even as a library that could be used is probably around another year or so. And to your point, I think we could probably look into some things like Enigma, which is a decentralized key-based management of achieving consistency is definitely interesting. The question, I guess, is still about the consensus of it when you're shifting from one network to another network, right? Like, I think that question is still unsolved, is what you're pointing out.
Mm-hmm.
Great discussion.
So how do we take that forward?
Yeah, I mean, I think we've got some stuff to do to carry it to the point where we're ready to like make that handoff, and then I think it's a matter of deciding how to do it at that point. And I think the way that we've designed it, it could go a few different ways, and it's flexible enough to go a few different ways. And in the meantime, it'd be interesting to understand, like, how I think we should look at it from the lens of the multi-party computation, probably, to understand, because really, like, if it works for two parties, great, but I mean, if it doesn't work for multiple parties, then beyond two, then it's kind of moot. I think that it's got to work. It's got to scale to every, to all the different use cases beyond two parties. And so I don't think we should just solve the problem in that base case context without really trying to solve it in the broader context. That's my thought, at least.
And most likely also, I'm not sure. Yeah, you mentioned it. That's anyway most likely a layer 2 solution that will happen anyway. But the scaling, gas costs, etc., could also become an issue. We would just try that. Because typically it just depends. If you're currently open on DeFi and make a vault and do actually take out a loan or redeem something, that is incredible amount of gas price you need to pay for that currently, and just considering to make that with an MPC scenario or some zero knowledge proofs, I guess that could be even more expensive. So what just did a repayment to a maker vault yesterday, and it was $3 gas price. So
I think layer 2 makes sense. You could even use layer 2 for consensus. If all the parties are online and you have a good protocol to ensure that they're all online, you could use generalized state channels for consensus and then do settlement. You can sort of like use that layer 2 channel for doing like.
Absolutely, I agree. Yeah, it wouldn't be possible otherwise. Yeah. The infrastructure itself on the mainnet, have you any estimate how expensive that might be to just do something like this token commitment, token minting?
Yeah, I think that's something that we haven't done that yet. Kartheek, I don't think you looked into that yet either. But, correct me if I'm wrong there, but I think that we've got a few more steps to take to sort of shore things up to get it to that point, and I think that there's like a spike that we could do to look into that. Yeah. I also think Connect's network, their layer 2 channel solution would be a really interesting opportunity to look into. I've done some advising on that project and talked to them about this a little bit. So I think that could be a next step too, to talk about layer 2. But we could first, see how much, just do some benchmarking around, what it would cost without that, and then go from there. It seems pretty reasonable. Kartheek, were you going to say something? Sorry.
No. I was, I was just alluding to the same thing, that I think it would one of the great insights we're getting from this meeting is that there is a whole gambit of
we lost him, I guess. Huh?
Oh. That was going to be good. Let's see. Maybe it's, and he's back. The last word we heard was gambit.
Right, but that and laptop got died out of battery, so it's trying to join through my phone. I was just saying that I think it's and then to the whole starting point, the originating point itself. I think there is a separate set of activities, because I think for the most part we've been, or at least looking at only the DeFi space about what needs to be done from, say, taking it from the point in time it is represented on a certain DeFi platform and how it could be further exchanged. But this meeting is great because the session has been great because it actually opens up a whole set of possibilities around what it means to take it from a local system to a settling system, even from a data perspective. Mm-hmm. I'll work with Kyle to see if we can set up some baseline rate sessions with this group to talk specifically around the multi-party aspects of it, both from a signature management perspective, areas maybe that we could leverage between layer 2 versus say something like Enigma even.
Sounds good. Yeah. Yeah. Martin, thanks a lot for your time today, and Stefan and Tomasz, you as well. I think this has been a good chat. Nice. I see Stefan's got his emoji reaction there. Sorry, just cracked me up. All right.
I can't switch it off though. I'm sorry, it just remains there.
It's just there now. Yeah. Oh.
It's because I'm so excited.
Excellent.
Awesome.
Thanks, guys.
Yeah, thank you.
Cheers.
Good remaining day.
Yeah.
Talking to you.
Yeah. You too.
Bye.
Cheers, everyone.